So let's see another important problem today, that is pivot or equilibrium index. Okay, so you would be given an array of integers. You need to calculate the pivot or equilibrium index of this array. Okay, so a pivot or equilibrium index is the index where the sum of all the numbers strictly to the left of the index is equal to sum of all the numbers strictly to the index's right. Okay, so let's see two examples. So you have an input array with the elements 1, 7, 3, 6, 5, 6. So here the pivot index is 3, that is 0, 1, 2, 3. So this is the pivot index. Okay, so this is the pivot index of this array. Okay, why it is the pivot index or the equilibrium index? Because the elements on the left, that is 1 plus 7 plus 3, that is 11, is equal to the sum of the elements on the right of the index, that is 5 plus 6 is also 11. Okay, so the pivot index is 3. Okay, 0, 1, 2, 3. Okay, let's see another example. We have an input array of 2, 1 and minus 1. So the pivot index here is 0. Okay, this is the pivot index or the equilibrium index. Why? Because there is nothing on the left of the left of this index. So the sum of the elements on the left is 0, and the sum of the elements on the right, that is 1 and minus 1, is also 0. So the pivot index is 0. Okay, so let's see how we achieve this through the code. Okay, I would strongly recommend you to please watch the previous videos of prefix sum. Okay, so there are two videos of prefix sum part 1 and prefix sum part 2. So I would strongly recommend you to watch those videos before proceeding to the solution of this problem. Okay, here in the main method we have an array consisting of the elements 2, 1, minus 3 and 0. Okay, and we are creating an object of the solution class, and by using that object we are calling the get equilibrium index method. Okay, with the array passed as its argument. Okay, so this is going to return either minus 1 or the index. So if it returns minus 1, then we don't have an equilibrium index or a pivot index in our solution, or else we have an equilibrium or a pivot index. Okay, so let's see the code. So we are fetching the array length first, and we are creating a prefix sum array, and we are looping over this original array, and we have started creating the prefix sum. Okay, so I have created a detailed video on prefix sum. So how to create this prefix sum array? So you can go and watch the prefix sum array part 1 video in the playlist, so that you will be able to get a fair idea of how prefix sum array is created. Okay, now once the prefix sum array is created, so we need to calculate the left and right sum of the array. Okay, left sum from the given index and the right sum from the given index. Okay, so here I have discussed a logic. Okay, and this logic I have discussed in a very detailed way in the prefix sum part 2 in the playlist. So please go and watch that video. It will be very helpful for you to get a clear understanding of what's going on here. Okay, so what I'm doing is, here I am creating a variable called let sum and right sum. Okay, and I'm looping over the array. Okay, so here if I is equal to 0, I'm initializing the left sum as 0. Okay, this part I'm going to explain it to you later. Okay, and the left sum I'm calculating as prefix sum of I minus 1, and right sum is prefix sum of n minus 1 minus prefix sum of I. Okay, so to understand this, why I have done this, so please watch the prefix sum part 2 of this playlist. Okay, and if left sum is equal to right sum, I am returning the equilibrium index, else I am returning minus 1. Okay, so let's execute and see what happens. Okay, Suppose I have an array 1, 2, minus 3. Here also in the right hand I have 1, 0 and 2. Okay, so what's going to be our equilibrium index? So 2 is going to be our equilibrium index. Okay, because the left sum here is 3 and here also the right sum is 3. Okay, so let's execute and see. So the equilibrium index here is 2. Okay, as I said, like, why have I given this condition here? Like, if I is equal to 0, then left sum is equal to 0. Okay, suppose you have 4 elements in the array 0, 1, minus 3, 2. Okay, so here at the 0th index you will be having left sum as 0 and right sum as 0. Getting my point? So if you calculate the left sum at the 0th index, so it is already 0, and the right sum index and the right sum, if you calculate, see, it comes to 0. So if you don't give this condition here, we might miss this edge case, okay, which is mentioned here. Okay, suppose if I remove this, okay, and I create an array intentionally where the equilibrium index is at the index 0. Okay, suppose the index 0 is 5. Okay, and in the right end of the array you have something called 3, 1, 0 and 2. Okay, so here the left sum is 0. Okay, and the right sum, that is minus 3 plus 1 plus 0 plus 2, is 0. Okay, so if I don't give that condition, what will happen? You see, sorry, I need to remove this. Okay, I'll execute again. Okay, so here you see what error it gave. It gave index minus 1 out of bounds for length 5. Okay, because here it's trying to access the minus 1 index, okay, which doesn't exist. Okay, so here you won't be able to test that particular edge case, and also you will get an index out of bound exception. Okay, so let's put that code again. So here this edge case will be handled where at the 0th index you will be having the equilibrium index. Okay, so there can be a situation where the equilibrium index can be at the very last index. Okay, so let's see whether that test case is handled here or not. What I'm trying to say is, suppose if at the last index you have something called 5, and in the left sum you have something called 2, 1 and minus 3. Okay, so 2 plus 1 plus minus 3 is equal to 0, and here also the right sum that is present after this index is also 0. Okay, so let's see whether this test case is handled or not. So here the left sum is equal to 0 and right sum is equal to 0. It's at index n minus 1. Okay, so let's see if this test case is handled or not. So what do? Okay, we move this 5 to the end index. Okay, minus 3, 1, 0 plus 2, minus 3 plus 1 plus 0 plus 2 is equal to 0. Okay, so let's see if this is handled or not. Okay, equilibrium index is at 4, so 0, 1, 2, 3, 4. So this is the equilibrium index. Okay, what all edge cases are we missing here then? Suppose if this array has one element, okay, so what's the equilibrium index? Here the left sum is 0 and the right sum is 0. So do we have an equilibrium index for this? Yeah, so the equilibrium index here is 0. I hope you are able to understand what I am trying to explain. Okay, So please like, comment, subscribe our channel if you like the explanation, and if you find any of the code is not correct, then please let us know in the comments. Okay, thank you for watching this video. Thank you.